You asked and we're answering. Whether you attended one of our PADS Professional Electrical Design Rule Check webinar events live or watched the recording on demand, some great questions were asked. So, let's get the answers. Hi there, I'm John McMillan and welcome back to another edition of this special series of PCB Tech Talks, the After the Webinar podcast series. In this special podcast series, I'll be joined by webinar presenters and we'll be answering and discussing the webinar questions. As always, be sure to subscribe to this podcast, let us know the topics you'd like to discuss, and if you'd like to be our guest right here on PCB Tech Talk. Today, I'm joined with our Electrical DRC webinar demo presenter, Rebecca Lord. Hi, Rebecca, and welcome to the After the Webinar series of PCB Tech Talk. How are you today?
I'm good. How are you, John?
I'm good. Welcome. I know this is your first podcast with me here, so why don't you tell folks a little bit about yourself before we get into the Q&A?
So my name is Rebecca, and I am a Hyperlinks SIPI TME technical marketing engineer at Mentor. I have about 5 years of previous hardware engineering experience in the data storage industry, and hopefully we can answer some of your questions today.
That's great. We've had excellent responses from this particular webinar. It's been very, very popular for a number of reasons, but I'm sure this one's going to get a lot of on-demand plays, and I know it already has. So let's just jump right into the questions. I was kind of surprised there weren't, the quantity we've had in some of the big general topics, but there were still some good questions that we can answer here. I'll jump in and take on the first one, which says, I worked with a team of hardware engineers. So how do I include them in the review process of what electrical DRC violations are so they can determine which ones are okay versus the ones that need to be fixed? And that was a very good question. And if they're not layout tool users, and Rebecca, jump in anytime you want, the PCB designer can just share the data, the design violations with others using the share list. And what that is, it's an HTML format, and it contains an image, the violation details, and the coordinates of each violation. So with that, they can easily flag the ones that they want to ignore and emphasize and give directions on which ones and how the other ones should be fixed.
Yeah, absolutely.
Take a next question.
Yeah, definitely. Here's one. How many rules come with the package? There are a few different rule packages that are available, so you can choose which one works best for your purposes. All of the packages range from about 22 rules to 71 rules. Is Hyperlinks DRC ready to use out of the box? Hyperlinks DRC is ready to go out of the box, but you'll also find that the rules are going to be most effective when they're tailored for your design specifications. And once you have your object list and your parameters completely set up, you're able to save that scheme and you can use it over and over again, which is another question. Can I set up all of my parameters and rules in a certain way? And can I retain those settings for future projects, which kind of leads into what I was just saying. Yes, you can definitely save all of your setup and setup data as either a local or a global template, and that way you can use it with iterations of the same design, and you can also use it for a completely different design as well.
Now, on the first question you had about the number of rules, I think you actually did a nice little screen capture there at the end of the list of all the different rules. So if you're watching it on demand, well, you can actually there's links to it actually in the show notes. But also, if you're watching on demand, you can freeze at that level and freeze the video and actually just read through all those if you want to just get the headline of each one of those. So that's really good information. So the next question is, what tools are under the hood for these electrical DRCs? And it uses Hyperlinks technology. So electrical DRC has built-in engines for geometric calculation, path finding, net topology extraction, along with the 2D field solver, which provides the quick and accurate results that you saw during Rebecca's demonstration. And all of this without the need for preparing device models. So those are the key technologies under the hood for electrical DRCs.
Can you use IBIS models with Hyperlinks DRC? The answer to that is yes. If you want to use IBIS models for your board components and you have those IBIS models, whether from the manufacturer for the part or if it was internal, You can import that into DRC, and the tool will automatically extract information from that IBIS model, information such as rise and fall time, voltage, and pin types, and that saves on time with manual adding in different values.
For the non-double E, that's a lot of PCB designers out there. How intuitive are these electrical rules to understand? And that's a very good question. As you saw again in Rebecca's demonstration, when you click on each rule, it has this very intuitive slide description screen that not only provides you with the purpose of the rule, but also the prerequisites and the parameters of the rule. And also helpful graphical representation. To me, pictures are worth 1,000 words, so it makes it really easy to understand. And there are also hyperlinks to additional information and related rules if you want to learn more. So all that's there, very intuitive, very informative, built right into the tool.
Why were you running rules on certain nets or components and not the entire design? That's actually a really good question that I've gotten a few different times. And the answer is that sometimes it does make sense to run a rule on the entire design. Depending on the rule and the specifics of your layout, running a check on the entire design might also just be unnecessary. For example, if you're running DDR topology rule, like flyby topology or something like that, it'll likely include false violations if you're running that rule on the entire design, because for a DDR topology rule, you're only going to be concerned with specific DDR nets. So that's why I was making those object lists for specific nets, because I knew I didn't want to run the design on the whole, or the rule on the whole design. But on the other hand, if you want to run like the metal island rule, you're probably going to do that on your whole design so that it'll check for isolated copper anywhere on your board.
That's a good point. So when is the best time to run electrical DRC? And that's another great question. And it really speaks to the whole shift left design acceleration flow. That is, you don't have to wait until you're done with the layout to run electrical DRCs. It can be run at any time. You can and should run them early and can run them often. In fact, you'll probably want to, because realistically, you wouldn't want to wait until the end of the layout to discover that you need to move traces that are crossing split planes or try to squeeze in additional decoupling capacitors. So the answer is as early and as often as you need to, and until you're satisfied with the results. So Rebecca, I have a question for you. So how do you use electrical DRC? What is when you plan it out in your mind, is there certain steps that you do it in the layout flow when you're doing them?
Yeah, I guess it kind of depends on the complexity of whatever the board is that I'm designing, but it would definitely make sense to do it all the way through the whole design process. If I have a whole section of the board done and I don't have the rest of it completed, it would make sense to run the rules just on that part of the board, and then you can make sure that it's going to be up to the standards that you want it to be, and then you can continue on with the rest of the design. And then also you can do it at the end to do the whole design to make sure that everything is working harmoniously with everything else. So it just is pretty design specific.
So let me ask you this. If, like the decoupling capacitor rule, is that something I would run pre-layout after placement, or is that something that still requires there to be routes in place before I can run that rule?
So the decoupling capacitor placement rule, that would be for decoupling capacitors on specific nets. And so you would probably want to have your nets routed that you're running that rule on, and then it'll check to make sure that those specific nets actually have decoupling capacitors on them. I have another one here. My design tool already includes layout DRCs. How is this different? So Hyperlink's DRC possesses rules that check from an advanced electrical perspective that layout DRCs are not capable of. The verification tool so Hyperlink's DRC is a lot more extensive and more powerful than any PCB layout DRC tool. And then there's another question here, which kind of is related to that. What if there's a rule that I want to run, but it isn't included out of the box? And so with the Hyperlink's DRC developer version, you actually have access to a custom script writing and debugging environment. And that can be extremely useful if you have unique rules that are completely customized for your flow and you need to kind of completely customize that whole thing. So the process, you can do it start to finish, write custom rules, and run them on your design.
Yeah, and I think that's an excellent point you bring up. I think we're emphasizing electrical DRCs when everyone, most tools, all tools have traditional DRCs, design rule checks. That's, trace to trace, line to line, component to line, component to trace, pad to VB to pad. Those are traditional DRCs. Those are the ones that are built into the tools. These are electrical DRCs, of course, powered by hyperlinks, are the ones that are going to give you all this electrical design rule check validation. So this is far beyond what's ever built into a standard layout tool. Do you have any more questions?
No, but I actually do kind of have a little story here from about how I really wish I would have had a DRC tool back when I was doing some design work, because I did end up, I was doing some really minor changes to this board, and I ended up having an isolated plane for it was supposed to be a voltage reference plane, and of course, since it ended up getting isolated when I was making some other completely random changes to my board, and nothing in my layout tool would have caught that. And so we actually ended up sending it out and getting it manufactured, only to come back and find out that my IC wasn't working at all because it didn't have power to it. And we had to go through this whole process of manual inspection with the Gerber files, and having a DRC in that, having Hyperlink's DRC in that situation would have saved us so much time.
Yeah, I can imagine. I've been the victim of that too, actually. And another thing that happens, I don't know if you've seen it, Rebecca, or not, but sometimes fabricators actually check and find these things, but that's not the person. That's not who we really want to actually be altering our artwork. Altering our Gerber files. We want to make sure that we catch and resolve all of those things, including DFM, DFA things that can get caught after the fact, and the time that it takes when you go back and forth in fabrication, and if they do identify those isolated islands, it can save a lot of time.
Yeah, exactly. Even if you have your PCB manufacturer catches the issue, and then they get back to you and say, oh, we have this problem, what do you want to do about it? That's still taking a pretty significant amount of time, because then you have to go back and rework the board in the PCB tool, and then you have to send it back over to them, and it adds time, where if you do this on the front end, you're going to save all that time later on.
Yep, you can save a respin, you can improve your time to market, ensure you don't miss schedules. Perfect. That's a great story. Anything else you want to add, Rebecca?
Not at the moment.
Okay, great. Well, thanks so much for joining me. Glad you came out today.
Yeah, thank you so much, John.
And thank you again for joining our third in this special After the Webinar series podcast. For more information on this podcast, as well as a link to the on-demand replay of the webinar discussing electrical DRC, be sure to check out the show notes. There, you'll also find additional information related to this podcast, along with my email address. So feel free to send me your comments and questions, or any topics you'd like to hear me talk about, or if you'd like to be my guest right here on PCB Tech Talk. I'm John McMillan. Thanks for listening, and be sure to subscribe to this podcast on iTunes, Spotify, or your favorite podcast app. And be sure to catch the next episode of PCB Tech Talk.